Okay, so the next little video is on the z-scores. I'll resist the temptation to call it z-scores. And the idea here, we have the cost per order, and you can see it's ranging from, say, 68 to 120. I think it was 127 or something. Um, but if you have lots of variables in a database, each of them is going to be on a different scale. The idea is if we subtract the mean and then divide by the standard deviation, we basically get everything on the same scale with a mean of 0 and a standard deviation of 1. And this is actually quite useful when we get onto other techniques if all our variables are on the same scale. So all that we're doing is we basically, 1, subtract the mean, 2, divide by the standard deviation, and then we get our variable in this standardized format where 99.7% of the observations are between -3 standard deviations and 3 standard deviations. So it's a measure of how far away we are, each item is away from the center, which is kind of independent of the actual scale of the data, which is why we have z-scores. So to start off with here, I've just kind of copied this over, copied and pasted from the main, paste values from the main purchase order databases. But let's just kind of add a little bit of information. So that's just the number of the observation. It doesn't really matter for this one. We've done this before. So 1, just select the bottom right, drag it down, and fill series. Not quite sure why the others are like formatted slightly different. We'll fix that in a minute. And then we're going to calculate a z-score. And we're going to calculate a z-score a second time. I'm going to call this z-score 2. But to calculate the z-score, we actually need, as I said, we're kind of subtracting the mean and dividing by the standard deviation. So what I'm going to do is I'm going to calculate the mean. And let's just say Control Shift, then bottom arrow. That's to 95, B2 to B95. So the mean equals average. And the standard deviation. And again, just let me check what I did before. Yeah, we're going to consider a sample, so we're going to use the sample standard deviation. B2 to B95. So we have the mean and the standard deviation. So all we're doing here is we have each value, we subtract the mean, and then we divide by the standard deviation. Now, let me just make sure that when we subtract the mean, this is in brackets, so we subtract the mean first. Each of these variables, we're going to drag down, so we need to put $1 here. I'll put $1 before the G, just in case we decide to drag across. And that's kind of sometimes actually a good thing to do because you don't know how you're going to change the spreadsheet. And there we have a z-score. Now Excel also has a function called standardize, which creates these standard variables. And here we put X, and you set the mean and the standard deviation. And voila, it's exactly the same thing. We drag down. Oh, and what was my mistake? I forgot to put my dollars in there. Happens to the best of us. So we drag down. And again, we get exactly the same values. So let's just look at our largest and smallest observation. I didn't have, these weren't ordered, but 68.75 is almost minus 1 standard deviation. We had, what's over 100,000? 121,000 down here. Here we are, 127,000. And you can see this is our largest value. It's like over 3 standard deviations above the mean. Okay, like this is looking horrible, so let's just make sure everything is in the correct font. It's a bit of a thing of mine. And also I'll do the same here. Which I could have just done it for the whole sheet, but never mind. Make this bold, and then we're going to underline this. And where are we? Okay, so it's all looking a lot better. So again, it's just this idea of the cost per order. We're getting it on this standard scale with a mean of 0, standard deviation of 1. And I kind of did it manually, and then I did it using the specific Excel function.